Okay, our next topic is stable and unstable system. Okay, what is the definition of stable and unstable system? A system which obeys the bounded input and bounded output principle, then the system is called as stable system. So that means when you give the bounded input to the system, if it produces the bounded output, then the system is stable, or otherwise it is unstable. So that means what? You are providing bounded input, but the output is unbounded. Okay, if the output is unbounded, then the system is unstable. Okay, so in both the cases you are providing the stable input. Okay, so system is there. Okay, system. Okay, so in the first case, say for example, you are providing bounded input. Okay, bounded input. Again, next we'll see what you mean by the bounded input, and then the system is giving some output, and that output also we are calling it as a bounded output. Okay, so then the system is, if this is the case, then the system is stable system. Okay, system is there. We do not know now at this point what is the properties of the system, but when you give the bounded input, the output is also bounded, then the system is called as stable system. Or otherwise there is some other system. Okay, for that system you are giving same bounded input. Okay, again you cannot say again, here also you are giving same bounded input, but the output is different here. See, this we will call it as a system number 1, and this is system number 2. Again, the system number 2 you are giving bounded input, but that output is unbounded output. Okay, the output is unbounded output. Then this system is called as unstable system. This system is called as unstable system. Okay, so now in this case the system number 1 is stable system, system number 2 is unstable system. But you see, in both the cases we have to give the bounded input. Okay, so suppose if for example if you are providing unbounded input, then you cannot analyze the stability of the system. Okay, so if you want to analyze the stability of the system, so definitely the input has to be bounded. Again, the output could be bounded or unbounded. Okay, if the system is stable, then the output is the output is bounded. If the system is unstable, okay, then the output will be unbounded. Okay, output will be unbounded. Again, what do you mean by this bounded input or bounded output? Okay, say again, in general the system properties mathematically will denote the system with help of h of t. Okay, h of t. H of t is the response of the system, system transfer function of the system. Okay, h of t is the transfer function of the system, and say for example x of t is the input of the system, and then y of t is the output of the system. Okay, so same things you might have studied in control system also. Okay, whenever the system is there, we will characterize the system with help of h of t, and the input is x of t and the output is y of t. So in time domain, whenever you are in time domain, what is the relationship between the input, output and the system impulse response? Okay, so the h of t in time domain, we'll call it as a system impulse response. Later I will come to that why this h of t is called as system impulse response. But y of t is x of t convolution with h of t. Again, you know, x of t is input, y of t is output. So what is that h of t? H of t we will call it as a impulse response of the system. Okay, in time domain this is called as impulse response of the system. Whereas in the frequency domain we'll call it as, you see, in frequency domain you can take Laplace transform. In frequency domain this is h of s. Okay, that time we'll call it as a transfer function of the system. Okay, so the transfer function of system. Again, you know already how to go from h2 to h of s. For that you have to take Laplace transform, that we'll be studying in the further units. Okay, so h of t means time domain, h of s means frequency domain. So frequency domain transfer function, time domain means we have to call it as a impulse response. Okay, and again this new operation is convolution operation. This new operation is convolution operation, and then later we'll see how to do the convolution operation. This is not the simple product, this is the convolution operation. Okay, so y of t is equal to x of t convolution with h of t, convolution with h of t, or otherwise we can write it in the frequency domain like this: y of s, y of t, y of s, x of t, x of s. Instead of this convolution operator we can put just dot, that means simple multiplication. Okay, so again for h of t this is h of s. Okay, so whenever you are in time domain you have to take the convolution operation. If you are in frequency domain, just you have to multiply the frequency response so that you will get the output response. Okay, so now we are in time domain, so we'll take this equation y of t. Y of t is convolution of the input with the impulse response of the system h of t. Again, why this h of t is called as impulse response? Okay, see, x of t is input. Okay, x of t is input, and y of t is output. Okay, y of t is output. See what happens when you substitute input as impulse. Okay, so in general the input could be anything. It could be impulse or step function or ramp function or any other function. Okay, so x of t could be anything. Okay, that is the input to the system. Suppose if the input is impulse signal means what? Del t. Okay, impulse signal. If the input is impulse signal, okay, then what will happen to the output? Okay, so when then you replace x of t with del t, you replace x of t with del t. So y of t is equal to already x of t convolution with h of t. Okay, then x of t, instead of x of t we have to put del t. Okay, del t convolution with h of t. Again in future we'll study the convolution of impulse function with any other function will provide that other function. Okay, it's like simply like one. Okay, so the convolution of impulse function with any other function will provide that function. Say for example, if impulse is there, if you are if you are doing convolution with some signal, say for example x of t, then what will be the answer? Again x of t only. Okay, so when you do the convolution of impulse with any other signal, you'll get that signal only. Okay, so again as per that concept, so you will be getting here h of t, and then later classes we will see how this is working out. Okay, so now at this moment y of t is equal to h of t. So that means what? When x of t is equal to del t, that means what? The input is impulse. Then what is the output? The output y of t is same as the system function. Okay, so that's why the h of t is called as impulse response of the system. See, that means what? The output of the system is what? When you provide input as impulse, that output we will call it as a impulse response of the system. So y of t is equal to h of t. That's why this is called as impulse response of the system. Okay, so impulse response means what? Output. Okay, so what is the output? Okay, when you provide input as a impulse, okay, that output we will call it as a impulse response. Okay, so that's why this h of t we are calling it as a impulse response of the output. Impulse response. Okay, impulse response. So impulse response means what? What is the output when you provide input as impulse? So that is the impulse response. Again, in the next, again in future you will be studying what is the step response. Okay, what is the step response? Say for example, the system is there. Okay, system is there. Say h of t. Again input is x of t. Again output is y of t. In general, y of t is equal to x of t convolution with h of t. Okay, then suppose if the input is step function means u of t, then you do the convolution with y of t, you will get some output. This output we will call it as a step response. Okay, now this output is step response. Okay, so what is the response of the system when you provide step as a input? That output is step response. Okay, so now the y of t is step response. So this is some basic relationship between the input, output, and h of t. H of t means in general that is impulse response, because h of t is same as what is the output when you provide input as impulse. Okay, so then what is the concept of bounded? What is the concept of bounded? You are having input. Again, please remember, whenever you have a system, okay, you are providing some input x of t, and then this input you think it like some waveform. Okay, you know all the inputs are like some waveform. Okay, again, what is the output? Output is y of t. Again, you will get some different waveform only. Okay, okay, so again the input could be step or impulse or any other finite duration signal. Okay, so whenever the waveform is there, again, how to identify whether the given signal x of t is bounded or unbounded? Again, it's very simple. So just you calculate the area under this signal. Okay, the area under this signal. What is the area under this signal? That I will call it as ax. That means area under the input. Okay, so whenever the signal is there, if you want to find out the overall area under the signal, then again you have to integrate from minus infinity to plus infinity x of t dt. Okay, so then if this integral is less than infinite, okay, that means some finite value, then x of t is bounded. Then x of t is bounded. Okay, so how to identify the boundedness? You calculate the area under the signal, overall area under the signal. If the area is not infinite, that means the area is finite, then the input is bounded. Okay, so similarly you calculate the area under the output. Okay, again minus infinity to plus infinite y of t dt. If ay is less than infinite, then y of t is also bounded. Y of t is also bounded. Then what about the system? What about the system? Again, just now we have denoted h of t. Okay, again, now at this moment we do not know what is the nature of this h of t, because we have seen what is x of t, what is y of t. Again, we'll see later what is the structure of h of t, but h of t is also, it's like a waveform. H of t is also like a waveform. Okay, so again, when it is a waveform, see, whenever the convolution operation is like this, output is equal to x of t, a convolution with h of t. Okay, or otherwise I will put it like this. Okay, is equal to y of t. Again, there is one concept here. The area under the signal is ax, dot product with area under the signal h. Okay, it is not a signal, it is a system. So but it is also something like a waveform. So once if it is a waveform, again you can calculate the area. Again, what is the area under the output signal? That is ay. See, for any system, okay, this the relation is to be definitely it will be satisfied. Okay, so this is the area concept. Okay, whenever the system is there, what is the area under the signal x of t, area under the system, then once if you multiply, simple multiplication, that will be the area under the output. Now we'll come to that. Suppose if this ax is bounded, say for example, if ax is bounded, what is the concept of stability? The concept of stability is the if the input is bounded, then output is also has to be bounded. Okay, when you provide bounded input, if the output is bounded, then the system is stable system. Again here, which one is denoting the system? H of t. Okay, so again if we see here, bounded multiplied with what will provide bounded? Anybody? What should be this unknown value? Either it should be bounded or unbounded. Anybody? I am having bounded. Bounded means
Bounded, sir.
yes, bounded. So the unknown value also has to be bounded. Okay, this also has to be bounded. So what is the other way? Other way here is, if the system is stable, okay, then the area under the system has to be finite. Area under the system has to be finite. Then finally we'll conclude the ah means area under the system. So minus infinity to plus infinite ht dt has to be less than infinite. Okay, so instead of worrying about input and output, once if you know h of t, directly you can tell whether the system is bounded or not, because h of t is denoting the system properties. See, h of t is the impulse response of the system. It is denoting the system properties. Impulse response, impulse response of system. Okay, so it is denoting the system properties. It is denoting the system properties. Okay, so finally we are analyzing the system properties, whether the system is stable or not. So instead of applying bounded input and getting the bounded output, what is the another way of analyzing the system? Just if you know h of t, you calculate the area under the signal area under h of t. Then if it is finite, then the system is stable. So finally there are two ways to identify the stability of the system. Okay, so two ways. uh, there are two ways to identify the stability of the system. What is the first way? Okay, first way is bounded input you are giving to the system, then whether the output is bounded or not. That is one way. Okay, you are giving bounded input, then you are analyzing whether what is the output, whether it is bounded or not. Or otherwise, what is the another way? If you know h of t, if you know h of t directly, you calculate minus infinity to plus infinity h of t dt. If it is less than infinite, then also it is stable. Okay, so in general there are two ways, but again if you see carefully, both are same only. Okay, we'll see both are actually telling the same concept. Okay, but once if you solve the problem, then we'll come to know that. Okay, what do you mean by this? Okay, so now but anyway, exam point of view, we'll be following the case 1, but case 1 and case 2 are exactly almost same, but mostly we'll be following the case 1 approach for exam point of view. Okay, the semester exam point of view will be following the case 1. Okay, so as per that case 1, how to find out the stable or unstable system? First, what we have to do? We have to apply the stable input. Okay, so that means x of t we are applying as del t. Again the question may arise whether del t is stable or not, but we may be defined as del t as unstable. But what is the concept of stability is telling? It's not about whether it is stable or not, but it's bounded, whether this is bounded or not. But if you see that this impulse is actually bounded, because area under the impulse is always 1. Area under the impulse is always 1. So definitely the impulse is bounded one. So you apply x of t is equal to del t, or x of n is equal to del n. Then you find what is y of t, because already you applied some bounded input. Then what is the output? Okay, so you have to find out what is y of t. Then already you know x of t is bounded, then you have to verify whether the output is bounded or not, whether the output is bounded. Then how to find out the boundedness of the output? You know what is y of t now. You calculate the area under y of t. If this overall area is less than infinite, then the given system is stable. Similarly for discrete system also same. So in case of discrete system, instead of integration you will have summation. Again if the summation value is finite, again the given system is stable. Okay, given system is stable. So mostly we will follow this approach. Again this approach also we can follow. So sometime we will try to do both. Almost both are same only. Okay, so check whether the given system is stable or unstable. Check whether the given system is stable or unstable. Given system is stable or unstable. Okay, so now I'll go by method 1. That one. Sorry, first we'll write the problems. There are y of t is equal to x of t minus x of t minus 2. Okay, whether the given system is stable or not. First, what is the step? Wherever x of t is there, you have to apply del t. Okay, that means what? For this is the, this is denoting some system. When this is the input, you are getting this output. So this is the system equation. Okay, so then we are going to find out what is the output when you apply x of t as impulse. Okay, so now you calculate what is y of t. Okay, now y of t is like impulse response because you are applying input as impulse. Now what is y of t now? That is wherever x of t is there, replace with del t. So del t minus del t minus 2. Then how to find out the area under the output? Okay, now this is the output due to this input. What is the area under this signal? That is integration minus infinity to plus infinity yt dt. Okay, integration minus infinity to plus infinity del t minus del t minus 2. Okay, so what is the area under this signal? Anybody? Okay, so I'll write it here. Ay is equal to minus infinity to plus infinite del t minus del t minus 2, okay, dt. Okay, what is the area? Anybody? How to find out the area under the signal? Okay, so you can split it off like this: minus infinity to plus infinite del t minus infinity to plus infinite del of t minus 2 del t. What is the area? Okay, so I think I don't know whether we have seen some basics regarding this or not. Okay, so now just I'll try to explain the basics behind this. Okay, whenever the impulse is there, how to find out the area under this impulse? Okay, first we'll area under the impulse, area under impulse. Okay, first what about the regular case? In general, in regular case, we will have impulse at t is equal to 0. Okay, then what will happen if we do the integration from minus infinity to plus infinite? That del t, we'll call it as 1. Okay, the area under the impulse is 1. But what is important, whether the given impulse is in between this range or not. Okay, yes, it is in between this range. Suppose, for example, impulse is there, okay, at t is equal to 0. Suppose I am doing integration from 5 to infinite. Okay, then I am doing like this. Okay, 5 to infinite del t is equal to 0. Okay, that means if you see here, you are doing integration from t is equal to 5. Okay, you are doing integration from t is equal to 5 to infinite, but from t is equal to 5 to infinite, nothing is there because impulse is there only at t is equal to 0. But if you are doing integration from 5 to infinite, nothing is there. That's why the area is 0. Okay, so area under this, for this condition, the area is 0. Or otherwise, sometime, suppose if the situation is like this, 5 to infinite del of t minus 7. Now, what is the answer for this one? Again, you know, del of t minus 7 means it is not the impulse at t is equal to 0, but it is the impulse at t is equal to 7. Okay, so exactly at t is equal to 7, we are having impulse. That is the concept of del t minus 7. So that means what? The impulse is present at t is equal to 7. But from where we are doing integration? We are doing integration from 5 to infinite. Okay, where will be that 5? 5 will be here. Okay, so now definitely from 5 to infinite, the impulse is there. That's why the answer for this one is 1. Okay, for this one is 1. Suppose if the question is like this, 5 to infinite, del of t minus 3, then what would be the answer? The answer is 0, because you are doing integration from 5 to infinite. Okay, but where is that impulse? Impulse is present at t is equal to 3. Then the answer is 0. So that means what? Whether the impulse is in between this integration limit or not. If it is there in between the integration limit, then the answer is 1. If it is not there, the answer is 0. So now, as per that concept, what will happen here? Whether del t is there in between minus infinity to plus infinity. Anybody? What is the answer for this? Please be quick. Yes.
1, sir.
1. Okay,
1,
so
sir.
1. Here, whether this impulse is there in between the limit or not.
0.
Yes, sir.
Not 0,
1,
it's
yes.
also 1. See, t is equal to 2. T is equal to 2, impulse is definitely in between this limit. So here also the value is 1. 1 minus 1 is 0. Again, this is finite. Okay, we have applied the bounded input, then output is also bounded. So that's why this system is stable system. This system is stable system. Okay, so system is stable. Okay, then what is the other way of doing this? The same question. Okay, for the first question alone I will solve by both method. Okay, method 2. Okay, so y of t is equal to x of t minus x of t minus 2. Now you know one thing, when x of t is equal to del t, we'll get y of t, but that y of t is what? H of t. That y of t is what? H of t. Okay, see, when you apply the input as impulse, the output is same as the impulse response. Okay, so the impulse response here is h of t. So h of t is sorry, h of t in this case is del t minus del t minus 2. Again, if you do the, if you calculate the area under this h, integration minus infinity to plus infinite h of t, again that is also 0. Again it is finite. So just you have to understand, whatever you are doing, that is same as this one. Okay, when you apply the input as impulse, definitely you will be getting some output, but that output is not a different output. That output is like a system response only, system impulse response. That's why either you go by the first method or second method, both are almost same. Okay, so next question. Y of t is equal to 2 into x of t, whether the given system is stable or not. Okay, what is the first step? Apply x of t is equal to del t. Now what is y of t? Y of t is equal to 2 del t. Okay, then calculate ay minus infinity to plus infinite. Okay, y of t dt minus infinity to plus infinite 2 into del t dt. What is the answer? 2, because 2 you can take out. Again, integration minus infinity to plus infinite del t is equal to 1. Again, 2 is a finite value. Okay, so this is finite. Okay, once if it is finite, again the system is stable. System is stable. Okay, third question. Y of n is equal to cos of x of n. Okay, now we are in discrete. Y of n is equal to cos of x of n. Okay, again, in the beginning, just looking into the system directly, we cannot say whether the system is stable or not. First of all, we have to apply our regular procedure. Okay, in later classes, we'll try to tell directly whether the given system is stable or unstable. Okay, so, the input is impulse, that is del n. Then what will be the output? Y of n is equal to cos of del n, cos of del n. Now we have to find out area under this y of n, that is ay. Ay is equal to summation n minus infinity to plus infinite yn. Okay, minus n minus infinity to plus infinite. What is y of n? Cos of del n. Okay, again n value varies from minus infinity to plus infinite, minus infinite to plus infinite. Okay, now if you see here, I'll write it in the next page. So finally ay is equal to summation n minus infinity to plus infinite cos of, okay, cos of del n. Okay, so again we cannot do infinite summation, but we'll try to apply some finite values. Okay, we'll see what happens. Say for example, suppose if I apply n is equal to minus infinite cos of del minus infinite. Okay, again the values are coming. So finally, say for example n could be minus 1 cos of minus 1. Again n value could be 0 cos 0. Similarly n value could be 1 cos 1. Sorry, not cos 1, del also will come inside. Okay, so cos of del minus 1, this is cos of del 0. Again here cos of del 1, cos of del 1, again cos of del 2, finally cos of del infinite. Now somebody tell me what is the value of cos of del minus infinite. Anybody? What is the value of del minus infinite? Any idea? Is it 0 or 1? Or otherwise, you forget about this one. What is the value of del of minus 1? Is it 0 or 1?
1, sir.
It's not 1. Again, see, you all forget about the definition of impulse. Okay, when we discuss about unit impulse, okay, unit impulse, generally say del t is equal to, for unit impulse, del t is equal to 1. Okay, del t is equal to 1 when again when t is equal to 0. Wait a bit. When t is equal to 0 and again 0 otherwise. Okay, when we define about the unit impulse, again sometime we might have put infinite also. Again there will be some confusion, but if it is a unit impulse, del t is equal to 1 when t is equal to 0. Okay, then 0 otherwise. Then what is the meaning of this? That means when t is equal to 0, the value is 1. When I put any other value other than 0, let it be negative value or positive value, let be del minus 1 or del plus 1, what is the value? 0 only. Okay, so please refer the basics. Okay, this is the definition of impulse. Okay, so that means what? Except this, in all other cases I will get 0 only. That means cos 0 plus cos 0, but in the middle I'll get cos 1. Middle I'll get cos 1. Again I'll be getting see, del 0 is 1, that's why cos 1. Then I'll get cos 0, again it gets continued. Okay, now what will happen? You are starting at 1, 1 plus 1 plus, like that it goes. Again in the intermediate you are having cos 1. What is the value of cos 1? Just try to calculate. Okay, then again this is 1. Okay, it goes up to infinite. Now you are adding infinite ones. Okay, when you add infinite ones, what is the value? When you add infinite one, is it finite or infinite? You are having infinite number of ones. If you add infinite number of ones, is it finite or infinite? Anybody? Infinite. Okay, so
Infinite.
infinite. So the answer is infinite. Answer is infinite, that is unbounded. Okay, unbounded. So when it is unbounded, it is unstable. When it is unbounded, it is unstable. Okay, and then next question, y of n is equal to log of x of n. Solution, again input is impulse del n, then what is the output? Y of n is equal to log of del n, then area under the output ay is equal to summation n minus infinity to plus infinite log of del n. Okay, then log of del minus infinite. Okay, then log of del 0. Okay, again before 0 we can also write minus 1. Okay, log of del minus 1 plus log of del 0 plus log of del 1, again finally log of del infinite. Okay, now what is del minus infinite? Okay, then up to that del minus 1. Okay, so when it is del 0, definitely that is log 1. Okay, for del 0 value is 1, that means log 1. So in the middle we'll be getting log 1. Okay, so in the middle we'll be getting log 1. Okay, then this is del 1 means 0. Okay, so that means we'll get log 0, again finally log infinite, sorry, that also 0. Okay, log 0, all are log 0. But this side if you see log of uh, again what is del minus 1. Okay, del minus 1 is also minus 1 is also 0, log 0. Okay, again log 0. Again, now what is the problem here? Anybody? See, in the middle I am having log 1, but on the edges I am having log 0. Now what is the final answer? Anybody? What is the value of log 1? Any idea? What is the value of log?
Zero, sir.
0.
Zero.
0. What is the value of log 0? Is that log is defined for 0?
No,
No,
sir.
sir.
Undefined, sir.
Undefined. Okay, so log is defined only for positive number. It is not defined for 0 or negative number. Okay, so that's why this is undefined. Okay, so this is also undefined. Okay, I'm not saying this is unbounded, but it is undefined. We do not know. Okay, so finally it is undefined. Okay, so that's why this is also not a stable system. We do not know what will be the output. So that's why again the output is the system is unstable. Okay, so this system is also unstable system. Okay, and then we'll see some extra questions. Next, y of n is equal to x of n cos omega n, whether the system is stable or not. Okay, so what is the input? X of n is equal to del n, then output y of n is equal to del n cos omega n. Okay, del n, because wherever xn is there you have to replace with del n. Again you should not change further functions. Okay, you write as it is. Okay, so that's why y of n is equal to del n cos omega n. Now what is the area under the output? Okay, that is ay summation n minus infinity to plus infinite del n cos omega n. Okay, so again this impulse function is coming in product. Okay, so previously we are having the impulse function only with the summation or integration, but now this is coming in with the product, because if you see here also n is there. Okay, in previous case and all we are not having this complexity, but here this is like some function, fixed function, but this is having n. Okay, so now how to analyze this function? Okay, say again directly there are some formulas are there. Okay, first we'll apply the values, again later we'll see how that formula is working out. Okay, so when you apply n is equal to minus infinite del minus infinite cos of minus infinite, okay, cos of minus infinite, again del minus 1 cos of minus omega. Okay, then if you apply 0 del 0 cos of 0 del 1 cos omega, and then finally del infinite cos infinite. Okay, then what is the value? Again we know except del 0. Okay, inside 0 is there, then only del will provide value of 1, or otherwise in all other cases, okay, the value will be 0. Okay, del of minus infinity is 0, minus 1 is also 0, again del 1 is also 0, so everything is 0 except that middle term. So what will happen? All are 0 0 except that middle term is del 0 cos 0. Okay, del 0 cos 0, again all are 0 only. Then what is the del 0 cos 0? Del 0 is 1. What is cos 0? Cos 0 is 1. Okay, so then what is the area? Area is finite. Okay, so the area under this signal is finite, so this is stable, okay. So then how to calculate this? Okay, what is the formula behind this that we should know? Say we are calculating summation y of n, that is summation n minus infinity to plus infinite del n, okay, cos of omega n. Okay, so what we have to do here? Okay, simply you write this function cos omega n as it is. Okay, then what is the value of n? Okay, what is the value of n? See, when this del n is valid, the del n is valid only when n is equal to 0. Okay, n is equal to 0, then you substitute that value here. Okay, cos of omega 0, so answer is 1. Okay, so instead of applying all the values directly, you can write this. Okay, so or otherwise if the situation is like this, say for example another situation again. Okay, so this is another situation. Suppose if the if you are calculating summation y of n, if the situation is like this, minus infinity to plus infinite del of n minus 2 cos of omega n, then how to calculate this? Again this is very simply cos omega n, when this cos omega n is valid only when n is equal to 2, because this impulse will be present only at n is equal to 2. Okay, so then you substitute n is equal to 2 here, so cos omega 2 is the answer. Okay, so whenever you are getting this format, okay, either it could be like a summation or integration. Okay, so this is the answer. So that means what? The value will be decided by the other function, but what is the time? The time is decided by the impulse. Okay, the time will be decided by the impulse. That time you have to substitute in the other function, that will give the final value. Okay, so and finally this system. Okay, so this system is stable system. Okay, so now the properties of the impulse we are seeing separately in the future class. I will give you the properties of impulse. Okay, there are some few properties are there, around 5 to 6 properties. Okay, in later classes I will give you the properties of the impulse. Okay, so the next question, y of t is equal to e power xt. Y of t is equal to e power xt. Then x of t is equal to del t. What is y of t? Y of t is equal to e power del t. E power del t. Then what is the area under the signal output? That is ay integration minus infinity to plus infinite e power del t dt. Okay, e power del t dt. What is the value of this? Okay, e power del t dt. Anybody, what is the value of this? Any idea whether this is finite or infinite? E power del t dt. Hmm? How to integrate this function? Any idea whether the answer is finite or infinite? Okay, so see, whenever the situation is like this, integration e power del t dt, again when this del t will be valid. Okay, the del t will be valid only when t is equal to 0. Okay, t is equal to 0. Okay, when t is equal to 0, this is like e. Okay, so e. In all other cases, okay, the del t value will be 0. Okay, it's like you have to imagine now. See, for example, whenever the integration is given like this, I can split it out like a small integral. Say the same integral I can split it up like this. Okay, because it is continuous. Okay, so now I can split like this, integral minus infinity to up to minus 1. Okay, e power del t dt, and then from say or otherwise even you can take up to 0. Okay, so minus 1, no problem. Again from minus 1 to, say for example, plus 1, minus 1 to plus 1 e power del t dt. Again, see, we do not need the exact answer, but what we need whether the answer is finite or infinite. Final answer is finite or infinite. That is most important. We don't need the exact answer, but we need whether the answer is finite or infinite. Then what is the behavior of del t when you are in between this time? Definitely del negative number is 0. That means e power 0, but e power 0 is 1. Okay, e power 0 is 1. Okay, so dt, and again when you are in between this minus 1 to plus 1, again del t value, but exactly at t is equal to 0, this is 1, but in all other cases it would be some value, no problem, but this is providing some value, no problem, some finite value. This could be finite, but what is the last one? Plus 1 to infinite, but this is 1 dt. So the middle integral may provide you finite value, but what about the extreme integral? This one and this one, this will provide infinite value. So finally, uh, infinite, infinite plus finite plus infinite, infinite. So finally infinite. So the output is unbounded. So this is unstable system. This is unstable system. Okay, so unstable. Next question. Y of t is equal to t x of minus t, whether the given system is stable or not. First apply input as del t. Okay, input as del t. When you apply input as del t, what is the output? Y of t is equal to t into del of minus t. Then find area under the output signal ay minus infinity to plus infinite y of t dt minus infinity to plus infinite. Okay, so this is t into del of minus t dt. Okay, dt. Yes, any idea what is the answer? The answer is finite or infinite? Yes, sir. Any idea? What could be the answer? Okay, so when this function is valid, okay, that t is valid only when t is equal to 0. The t is valid only when t is equal to 0. Okay, so what could be the answer? Okay, if you apply the integration properties for impulse, see, you can do like this. Say t is minus infinite. Again, just I am splitting the integral. Okay, if you again this impulse, okay, del of minus t, this impulse is valid only at t is equal to 0. When you put t is equal to 0, this is 0. Okay, in all other cases definitely the function will be 0 only. Okay, again, but exactly at t is equal to 0 also this is like 0. So what is happening? Okay, so the answer is something like, it's like 0. So this is also, it's like a stable system. Again, there are some confusion. Okay, we'll verify that. Okay, this is also like a stable system. Stable system. Okay, final, next and final question. Y of n is equal to x of n square plus xn. Solution: substitute xn is equal to del n. Then what is the output? Yn is equal to del n square plus del n. Then area ay is equal to summation n minus infinite to plus infinite y of n, summation minus infinite to plus infinite del of n square plus del n. So again, it's very simple. Again, you can split this integral into two part, n minus infinity to plus infinite del of n square. Okay, again summation minus infinity to plus infinite del n. Okay, to del n. Then what is the value here? Okay, so you can substitute n is equal to any value, no problem, from minus infinity to plus infinite. But when you substitute n is equal to 0, this will be del 0. That time only you will be getting 1. In all other cases, you will be getting zeros. Here also you will be getting zeros. Similarly, here also, when you substitute n is equal to 1, you will be getting 1. In all other cases, you will be getting 0. Here also, you will be getting zeros. So finally, the answer is only 2, that is finite. So this system is stable system. This system is also a stable system. Okay. Um, okay. Now we'll stop